Okay guys, folks, what we're going to do today is we're going to be looking at algebra, and we're going to look at the visual representation of algebra. This week we're going to be working through several steps, and the first thing you're going to do is on your assignment is I give you 4 of these patterns like this, where I give you 3 cases and you need to answer 4 questions. And the questions are listed there, and I'm going to go through that first. So right away when you look at this, what do you feel like there's a pattern here? There's a pattern that we want to identify, and we notice that there's case 1, case 2, case 3, and then I might ask, well, what do you think case 4 would look like? What do you think case 4? If case 1 is just these little towers here, and case 2 looks like this, case 3 looks like this, what would case 4 look like? Well, yeah, I noticed that in case 1, there's a stack of 1 2-block here. In case 2, there's a stack of 2 case blocks here. In case 3, there's a stack of 3 of these little tower blocks here. And then I just add the 2 on the end. So case 4 would be, I think, 4 blocks all stacked on top of each other. But it wouldn't just be these 4 blocks. I noticed that there's 2 blocks on each side, like so. So I think that's what case 4 would look like. And you could do case 5 and so on and so forth. And the first question I'll always ask you is, what do you notice? Do you see any changes in the blocks between as the cases go up or the cases go down? Yeah, I noticed that the blocks are increasing, right? And specifically, we're adding 2 more blocks every time from our cases. So it's increasing by 2, right? So our case number is increasing. And I noticed that in case 1, there's 2 blocks. In case 2, there's a 4-block section. Case 3, there's a 6-block section, plus these 2 at the end, which we'll look at later. In case 4, there's this 8-block section. Okay, and that's the pattern I see. The other second question, and this might not apply to this as much, but it says, where do you see the new squares appearing? Well, I noticed the new squares always, so these 2 got added, then these 2 got added, and these 2. And you might have noticed somewhere different, and maybe you noticed that 2 on the side got added each time, and that's fine also. But this is just kind of where I was going with this, and that's the beauty of algebra, that we could see this way, the pattern in different ways, and that's totally fine. Now, the question says, well, what about case 15? Do you folks know what case 15 would look like? If case 1, 2, 3, and 4 would look like this, case 15, what would that look like? Now, we could draw out case 5, case 6, case 7, and so on all the way up to 15, but I noticed the pattern. I noticed in case 1, there's 2 blocks here. In case 2, there's 2 blocks. Case 3, there's 3 2 blocks. Case 4, there's 4 2 blocks. And case 15, what do you think? How many of these 2 blocks will case 15 have? Yeah, it will have 15 2 blocks. So I'm going to draw that out, and you're going to have to draw out case 15 for all the examples here. So let's go 1, 2, 4, 5, 6, 8, 9, 10, 12, 13, 14, 15. So I had a little much. Oops. That's 1, 2, 3. There's 15 there, plus the 2 on the end, right? Because I have to add the 2 on the end afterwards, and we notice that there's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 of these 2 blocks, and then I added the 2 on the end. And the last question, I'm not going to answer that here because I don't want to spoil anything, but it said, what do you think case -3 would look like? So what if we went this way? Think about that. How do you think the blocks are going to change as you go down in cases? Case 0, case -1. Is that possible? Right? What do you think? Is there a possibility for this of a case -3? I don't know. You tell me. Okay, I want you to pause this video here and go and answer the first section of your assignment. Okay, find these patterns out for the 4 patterns I give you. Okay, well, welcome back. And what we're doing now is the second part of your assignment. Now that you've looked at the patterns, and this part will not be nearly as effective if you haven't gone back and done the first part where you notice patterns, because this part gets a little more into the math of things, of the numbers and how we relate the pictures to the numbers. Okay, and the first thing it says is make a table of values. And we talked a little, we haven't looked at table of values too much, but a table of values just relates 2 things. In this case, we're going to relate the case number to the number of blocks. Okay, and this is going to be for every one of your table of values, so you could follow along and do that. Okay, so case number to the number of blocks. So case 1, 2, 3, 4, and so on. So if we go up and we say, okay, in case 1, how many blocks were there? Well, there were 2 here, plus the 2 we add on the end. So that would be 4 blocks for case 1. And we go back, how many blocks in case 2? Well, we had 2 stacks of 2, so that's 4, plus the 2 at the end, which is 6. Case 3, I noticed that we had 3 stacks of 3, which is 6 blocks, plus the 2 on the end, so that's 8. And lastly, case 4, I had 4 2 blocks, and plus the 2 on the end, which is going to be 10 blocks total. Okay, from this it says make a coordinate graph to illustrate this pattern. Well, we have case down here, and we have blocks over here, so let's make a graph. And we looked at graphing near the beginning of the year, so maybe you have to go review how to make a graph, X and Y, remember that. And I'm going to just, remember you don't have to use every line. I like to skip count by 2s here, where this is, well, like 1, 2, 3, 4, and I'll have each block as 1, where this is 2, 4, 6, 8, 10, and we could even go 12 up here. So here, making the graph, what we're going to do is plot these points. Remember, these are like ordered pairs, 1 and 4, 2 and 6, 3 and 8, 4 and 10. Okay, so I'm going to plot these over here. So 1 and 4 goes right there. 2 and 6 goes right here. 3 and 8 goes right here. And 4 and 10 goes right here. Awesome. Well, what do you notice about these blocks? Like, what do you notice between the case and the blocks and the dots? What are they making? Yeah, they're making a straight line through here, and it's going to extrapolate through. And we're going to, not today, but we're going to eventually get to a place where I say, well, what about a case 1.5? Could we have a case 1.5? What would that look like? Is that possible? And that's going to be a thing that we're going to view in the future. Maybe you know what case 1.5 looks like, right? Maybe not. I don't know. But that's going to be something we'll talk about later. Then the last 2 is more getting to creating an algebraic expression. It says describe the pattern, the way the pattern is increasing or decreasing. Well, this pattern is increasing, right? As the case increases, right? As the case number increases, we notice 2 blocks are added on each time. right? And this is just what do you notice with the pattern. Some patterns don't change the number of blocks, but maybe change the orientation of the blocks. And you'll need to look at that as well. And it says, describe your function using an algebraic expression. And we don't know what that is yet, so let's talk about that a little bit. An algebraic expression is something that relates any case number to any amount of blocks. So case 1 is 4 blocks, case 2 is 6 blocks, case 3 is 8 blocks, and case 4 is 10 blocks. So what would case 20 be, right? What would case 23 be? And any amount. So what I'm going to do is use a variable, x, to represent case. So x equals case number, right? Because it says describe the function using an algebraic expression that shows the number of blocks in each case. So we want the case number. We're going to, depending what case number is, we could find the number of blocks, okay? And so what pattern, how do we notice that 1 relates to 4, 2 relates to 6, 3 relates to 8, and we notice it goes up by 2, but that doesn't help us that much right now. But if I go back to our picture, we could see a pattern. Each case is times 2 plus the 2 on the end, right? Because case 3 is 3 times 2, which equals these 6 blocks, plus the 2 on the end. So we know that the algebraic expression could be 2 times the case number, which I'm going to say is x, plus the 2 that we add on to the end. So 2x plus 2, okay? And now x could be any case number, right? So if it was case 1, it would be 2 times 1 plus 2, which equals 4, right? And that checks out. But what if I said, what is case 100? Well, you could go 2 times 100 plus 2. 2 times 100 is 200, plus 2 is 202. Right? So we could say, well, case 100 has 202 blocks. And we could use this to find really large cases because we could draw it out, but even 15 took a while. Imagine what it would be like to draw out case 1000, right? And I want you to try this and do this for the next, the 4 exercises as you go through. I hope this video has helped, and be sure to email me or drop in to my meets whenever you have a question. Take care.